As robots become common in our daily lives, they are predicted to share our environment and perform tasks next to humans. Social psychology studies indicate that performing a task next to others leads to a social comparison. When people compare themselves with those who outperform them, known as upward comparison, they commonly report a negative experience. On the other hand, the comparison to those who are underperforming them, known as downward comparison, commonly leads to a positive experience. In this study, we evaluated whether solely performing a task alongside a robot would impact participants' sense of control and their overall performance. We predicted that the tendency to overestimate robot capabilities would lead to an upward comparison, which would decrease participants' performance and sense of control. In the experiment, participants were asked to perform a simple search task alongside a robotic dog. They were invited to an outdoor space and were instructed to look for an X symbol on cubes organized in 2 columns. We designed a simple task and organized the cubes based on Gestalt principles to establish a clear and efficient search pattern. To test the robot's impact, we applied a between-participant experimental design. In the experimental condition, participants performed the search task alongside a robot that was presented as performing search training. The robot began to search a few seconds before the participant and search in a fixed, inefficient pattern. In the baseline condition, the robot performed the task only after the participant completed their search. Our findings indicate that performing a task alongside a robot decreased participants' sense of control, led to a less efficient searching pattern, and decreased performance accuracy. The interview analysis revealed that almost all participants in the experimental condition perceived the robot performance as superior and overestimate its abilities. In the baseline condition, participants describe upward or downward comparison to the same extent. We conclude that the robot designers should carefully consider the impact of robots who perform tasks alongside humans, even when the interaction does not involve direct collaboration and despite the independence between the human and the robot's performance. Designers should consider methods for overcoming this effect, like raising people awareness of possible robotic errors and designing interactions that preserve some aspect of human control over the robot throughout the interaction.